Today, we are interviewing Duncan, the Process Equipment Technology Manager at Boecker, Niagara. Duncan will discuss how modern diagnostic tools are transforming the way producers approach screening performance, reliability, and maintenance planning. Welcome, Duncan.
Thank you. Thank you for having me.
No problem at all. Thank you for coming. So our first question, from your perspective, why are diagnostics becoming such a critical part of modern screening operations in mining today?
Yeah, it's growing much more, for sure. As you know, everything in this world is being diagnosed from your fridge, your stove, and vibrating screens as well. When I started back in 1990, I'm getting to be one of the old guys in engineering, I used to use sticky notes and a large probe, etc., to get the RPMs, etc., and it did the trick for that time period. But of course, it wasn't very precise. It was precise at limitations. So nowadays, number one, there's a shortage of people in the industry as far as skilled labor, people who understand, in particular, vibrating screens. And that knowledge isn't always being passed down, or it's hidden or kept within a smaller group. So diagnostics is good because, number one, it alerts you or gives you a heads up that something's going on with your vibrating screen. So it allows someone to go take a look at the machine, see what's happening. The other good advantage, or big advantage too, is that you can be more proactive. Nowadays, you're always looking for producing more, getting more out of your mine, and just having diagnostics gives you a heads up so that you can start to predict when things are going to happen.
That's great. Many sites still rely heavily on visual inspections and, of course, reactive maintenance based on that. So what limitations does that approach create for vibrating screens?
Yeah, visual is still a good way to go, but it doesn't tell the whole story. Similar, again, let's take your car, for instance. You take it in, they hook it up to a diagnostics and determine what's going on in the engine. And very much our diagnostics is monitoring a band of frequencies to give you an idea of what's happening inside of that machine. So to give you an example, you might have the bearings, the bolts on the bearings might be starting to come loose. And it might be just on the infancy stages. So that movement, you may not visualize it. It's behind guards. There's a lot of noise all the way going on all around the machine. So with the diagnostics, you're able to see visually. So it takes what's happening with the machine, puts it into a report form that you visually can see what's happening. So you can look for noise, so to speak, in the circles, irregular circles, low G-force, and things like that, which could be affecting your operation greatly. Or again, looking down that road of trying to get ahead of the curve and predict what's going to happen.
That's great, thank you. So for operations that haven't used those diagnostic tools before, what options are available today? How do they help producers better understand what's really happening inside their machines?
So with Haber and Boecker, we have three main diagnostic tools available. The one would be the pulse vibration analysis, which is utilizing accelerometers, which you have magnets on these accelerometers. You can put them on the corners and towards the middle of your machine. And in a moment in time, you can see what's going on. Again, it gives you that visual showing the circles, the G-force, the RPMs, which are all critical to getting the proper stratification in the material. So that would be the first, let's say, approach. The second would be the pulse impact, which is monitoring or seeing what your frequency of your machine is versus the frequency of the body, and making sure that you don't want those two to line up, otherwise it could lead to breaking of side plates, etc., or resonance, essentially, if you will. And then the third one would be the long-term monitoring, which is pulse condition monitoring, where you, again, utilizing accelerometers that are permanently fastened to the vibrating screen, and you're looking for trends. You're looking for a trend to see when it's running, again, outside of that band of frequencies that you're monitoring, looking for times that something is going bad, a bearing or a loose bolt or something loose. So it gives you error messages, if you will.
That's great. Thank you. So what types of issues can vibration analysis and condition monitoring uncover that operators may not detect through visual inspections or their own routine checks?
For many years, the vibrating screen's been used as a box that shakes, and certainly it is a box and it does shake, but to get proper stratification, which is the throwing of the material, you want to be able to have it dialed in at the proper G-force, that the larger rocks are going to the top, the smaller ones are going to the bottom, and each particle is presenting itself to the opening to pass or not pass. So it's probability, essentially, the screening, your probability to that rock to pass. But in order to achieve that, and have that each rock has an equal opportunity, it needs to be running at the proper G-force. So the condition monitoring or pulse VA is, again, what's helping monitor that, how the machine runs, and making sure that it's running at 4 Gs, and that it's the circle, the action of the circles is good, that you don't have a racking action happening which is leading to breakage, etc. So it's really giving you a lot of insight that you won't necessarily see with the naked eye or even hear what's going on.
That's great. So what role does Havre and Boecker Niagara play in helping customers not only collect data but also interpret the data and apply it effectively?
Yeah, that's a big subject. I had a person in the steel industry talk to me, and we were showing him again our condition monitoring and that, and he said to me, he says, you know, I can get a lot of data from a lot of different sources, but I need to know in that moment in time, the data you're getting out of there, what do I have to do? Do I have to turn this bolt? Do I have to make it run faster, slower, etc.? And he was very right in that. And what we've done to help facilitate that is, number one, we have a reliability engineer on staff full time. He is monitoring the error messages or any notifications that we receive when we use the pulse condition monitoring. He's also conducting training. He's looking deeper and deeper and being able to transfer that knowledge, or not so much the knowledge, but the interpretation of the results. As that one gentleman who said to me, he needs to know, when I see this, what do I do to help make my production? Yes, how to react. Yeah. And that's a lot of it. And again, all along that predictive maintenance cycle.
That's great. Our last question today, for producers who are just beginning to explore diagnostics, what is the first step that you recommend to start seeing, meaningful improvements in the screen performance?
I would say the pulse vibration analysis, or pulse VA as we call it, is a great, let's call it, introductory way to look at your machine. So it's a low cost impact on you, and it also will help predict and show how diagnostics can help you that your machine's running correctly. Again, when you look at a vibrating screen, sometimes there is obvious things, loose bolts, noises, etc. But sometimes things such as low G-force. So when a machine is running at a slower RPM or improper circle or stroke, it's not throwing that rock at the proper stratification. So the pulse condition monitoring, or pulse VA, gives you, again, a snapshot in time at that moment so that you can see how well the machine, the health of that machine, and how well it's working. And it's not just even for our screens, we can do competitor screens as well. We can, anything that is a circular or linear type movement, our condition monitoring can help, pulse condition monitoring can help you to improve your business, improve so that you get more productivity, less downtime, and can do more in a lot of ways with less people.
So Duncan, thank you so much for this information and for being here today. Thank you.
You're very welcome.
Thank you. Thank you.